Hey guys, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my water jet video series. So we just got in. I haven't had the time to get this stuff quoted. I just got in the hosing here. So the hosing is red. I wish that it was green. I mean, it's always paint it. Doesn't really matter. It's red hosing. It is very rigid, so I am slightly worried. It does have some saran wrap here, so I haven't even inspected this guy yet. I mean, it looks really good, so there's that. And this again was something that they had in stock, sitting there. Oh, it's a Spur Star. Okay, so a Spur Star. And let's see. Actually, no, it's not that bad. It's got some movement to it. I would say it's probably, like they said, about a 6-inch bend radius. So it's about a 6-inch bend radius there. The ends are crimped. They have this steel connection on it. So the end, in that piece is about a that piece is about almost 2 inches. So that last 2 inches there is not flexible at all. And then it has like a little nipple that is threaded into the end. And then it has a little flare fitting on it, right? Oh, and it has a collar. Is this a collar? I'm pretty sure it's a collar. And I think it's got a collar threaded on it, just like we have in our drawing. So it's basically the exact same thing that we have, where it has that thread on the nipple itself, and it has the SST piece over the top. SST piece is really nice. Actually, it looks like it's milled from the top down, so some sort of rotary, it looks like. And then it's got some sort of grinding to make sure that it's flat. That's kind of weird. Anyways, the machining itself here looks really, really good. The machining on the tube looks really, really good. The machining on the collar looks really, really good. So a lot of this is really good. The machining on the hose is kind of... There's some sort of number on there. It looks like a date. Anyways, oh, I think it's the batch number. It says batch number here. So this is a Spirostar, Spear Star, and it does say here 40,600 psi. So really, I mean, I probably could have got it directly from Spirostar, made in Germany, right here. So like I said, most of these guys are made in Germany. I probably could have got it from Spirostar for cheaper, but I wanted to at least get these guys something for their engineering work on this project. So I don't feel bad for probably overpaying for this guy, because these guys helped me out with the engineering work. And it comes with these little caps on the end to protect the nozzle. I mean, the fitting itself, it did come with one of the caps was off. So it does look really, really nice. And it is definitely flexible. So it's flexible inwards. It's not so flexible outwards. Yeah, it likes to flex one specific way, the way that it's been wound, right? So obviously that's the way that I'm going to have it hook up, go up towards the printer itself. So maybe I'm going to have to build some sort of support pulley thing, because again, this is 10 feet. So the only other way that I could think of is I could coil it how it is right now. It's basically in 3 coils here. And remember, this is a 10-foot hose. And the only other way is they would have to cut it, and that was going to cost a lot more. So this is a 10-foot hose, so I might have to coil it once, and then that will be probably enough to get to where I need to get it to. But overall, very, very nice quality. It's going to look super sweet on my setup here. So we have basically all we need to confirm these dimensions and then move forward. So what we're going to do is we are going to indeed confirm these dimensions and move forward and get these things quoted, and we will buy the frame itself. I mean, obviously I'm going to need some place to store this at some point until it's ready to go, or I'm going to have to move my toolbox out of here and get my brother to use that toolbox. So here we have it. So we're going to take one fitting off and we're going to take some measurements. So this end should be the 9/16. So let's go ahead and take a look here. I have my origin cal, my eye gauging. Okay, so 9/16, that's over 1/2 inch by 62 thousandths. It is indeed 62 thousandths. The collar is 50 thousandths, is 0.375 is the collar for this guy. And the outside, what wrench you use is a 0.6, it's 0.617. 0.617. I have a fraction thing on this caliper, so let's go ahead and see if it'll give me a fraction. It says 79 1/28. So let's go back to inches. It might be a millimeter, actually. If it's made in Germany, it's in millimeters. So let's see. It's 15 millimeters, 15.6 millimeters. So 15 millimeters and some change. But then again, this is a 1/4 inch tubing, so it might be that way. But what it looks like is, it looks like these this nipple is just threaded into the end of this tubing. And the tubing OD, by the way, if you're curious, is about 12 millimeters, pretty close. It is almost 1/2 inch. It's 4.5, and it's very, very rigid. I mean, obviously it's stainless steel on the inside, so that's good. Yeah, so one of the things I wanted to measure was the actual diameter of this hole. So let's see if it's possible to do that. So the hole in the tube is approximately 83 thou, which I'm pretty sure that's what I did. And then we're going to measure how far back this is. Looks like I didn't do... Okay, so this needs to be a little bit less than what it is. 0.083. So that's basically what it's going to look like there. That is the length. And so the length here should be approximately 81. Oh, no, it should be taller. It's taller now. So that's another thing. Is this angle actually... Oh, but this is actually the diameter of the hole, so this needs to be bigger. So let's say it's 0.1 divided by 2. And this piece here is approximately about 1/10. And then this depth is about 1/10. Oops. Yeah, so this is a little bit bigger. little bit bigger. How big is this actually? Yeah, it's about 140. 140. Yeah, so I'm about right there. This is about 140. Yeah, I would say pretty much 140. And then this hole here, this hole is, what? Should be over constrained. This hole here again is yeah, it's about 80, 78. I'm gonna say it's about 80 because, you know, limitations with calipers, right? Finish. And there it is. That's pretty much what it looks like. Cool. So that is the hosing. And let's see here on this 9/16. This 9/16 is, so it has a little cutout here. I don't know what the point of that is. It's got like this little shoulder where it's not threaded. Really not much of a point there. But it is actually I could use this way. It is approximately 1/2 an inch tall. So let's see with ours. So ours is quite a bit taller. This is only 1/2 an inch tall. Yeah, only about 1/2 an inch tall. Interesting. Now what about their collar? I can't see obviously how tall it is, and it's really tight on there. If not, it's welded or something. It's very, very tight on there. But like I said, I'm not going to be able to see how it is on there. So let's see here. So this is, sorry about the 0.371. No, pretty close. But definitely more meaty than I'm thinking. 0.371. So let's just kind of wondering if I should keep my own, because this might be an issue of, I mean, this basically could be a lot bigger. This doesn't need to be as big as it is. This could just be an 1/8 inch on each side. This is probably about an 1/8 of an inch on each side. Where that shoulder is about 1/16. I really don't know why it has a shoulder on there. Shoulder's not necessary. This is very nice though. It's very nicely machined. Everything's nice and smooth. It doesn't really need to be that way. I mean, the tubing does. The tubing needs to be basically as smooth as possible. Make sure there's no debris so it doesn't leak, at 30,000 psi. Okay, so anything else that we need here? The OD on this tubing is 245. So quarter 20. Alright, so looks good. So it's going to go in the cutting head. And it should be relatively easy to flex, and then I'm going to probably have to do one winding, or it's just kind of, maybe I'll use that area there to hold it up. So I'll hold it up in the winding to take rid of some of the weight, because it does have weight. It does have some weight to it, and I don't want it to be kind of sitting on this head. So I'll probably have something coming down and suspending it from the ceiling or something. Something coming down from the ceiling and tying around the top of this thing. And then it will have to do a little rotation here. This hoop here is probably 2 feet, I'm going to say. Let me see if I straighten my legs. Up to my knees. Yeah, let's say 2.5 feet or so. It's about a 2.5 feet loop here, so that means 2.5 feet. Pi d 6, let's say 8, say like 8, so that can't be possible. It's got to be like 6 feet. Do one loop, so it's got to be like 2 feet, so that's 6.25. 6 feet and 4 left? No, because you have at least 2 loops here. You have 3.5 loops. So if you have 10 feet, and 10 feet I think is subtracting the places where you connect up to. So 10 feet divided by 2.5 loops. So each loop is approximately 4 feet divided by 3.14. That's 1.3 feet. Okay, so each loop is approximately 4 feet, so that means that I have 6 feet left over, and that's kind of what I was looking for. So we're just going to have a loop here, and then what they'll do is later on, if I move the machine or whatever, and I put it higher, if I don't want to bend over, I could still put the pump on the ground and have it go up through the side of a table or something. So that's just going to help with later on installing this machine. So I'm going to have one loop stay there, and then I'll suspend it from the ceiling, the ceiling or the side of the table or something, side of a shelf. We'll come down with a little wire and suspend it there. It'll hold it up, so all it has to do is just the cutting head has to move this thing around, but with the Core XY and some upgraded motors, it shouldn't have any issues moving this head around. So now we are ready to get the rest of the parts and start cutting. So we need of course we need the body, we need the Core XY, we need to go to Tronxy and order the Core XY, and then we need to get the motors, and they're going to send me motors. And then they have the plastic corner pieces, which I need to make metal corner pieces. I need to make metal corner pieces both on this one and on the water jet, but that could be the first thing I cut, is the things to put the motors on. And then we need to build the water tank, and then we need to work on the programming to be able to switch on a air solenoid, and also basically flip a relay to switch on the air solenoid and also the water solenoid to let the water in and do that. So, and obviously we need to build the rest of the other two components, which are the manifold. Is basically the only thing that we need to build, is to bend that manifold, and then for the rest of this it's just brass fittings, and then go up to and then you just have a regular G38 air line go up to this fitting on the side, and regular brass fittings with a T go up to the front, and then attach a hose to that, and attach it to the bottom of this tank with some filter in it. So I need to build that. I need to just buy the body, and I need to build the tank, the manifold, and then do the programming, and that's pretty much it. And then order a couple more parts. In the meantime, I'll probably order those parts that I showed you guys on one of the previous videos, and then we could try. So we need at least to do that probably before I'm gonna order the frame, because that's gonna take up a lot of space. Right now, this is not taking up a lot of space. I'm just probably gonna build the build all the water shooting side, and then so we could do a test and see how that works and see what type of pressure we're getting. So that looks pretty good. Yeah. All right. Oh, let's put the fitting back on there so we don't get any cat hair in there. My cat's over here sleeping on my bed. But very, very excited. This is very close, and I don't know if I told you guys, but I got my the shredders that this is going to be used to manufacture. I just got a set of 8 in, and this is going to save a whole lot of money. So I don't think we really need to change much. This is okay. I mean, we can change some stuff if you wanted to. You know, this might be a little thick, 1/8 inch on each side, right? 0.325. So that's a difference of 2.45. So that's about 1/8 inch each side. Collar. .25, 0.325. So that's, and obviously it's minus some in some areas. So let's actually see that. Let's go inspect section analysis. Really, I don't think it's going to be that big of an issue, but we could kind of go with what they're doing here, and we could probably beef this up a little bit more. So let's take a look at this one more time, and let's make some of these changes. I mean, we're just going to make the changes in the collar. The depth we could keep the same, but we're just going to make some changes as far as the diameter of the collar and stuff, because again, we want to be 2-spec, and if this is on the hose, then it's 2-spec. So, oops. And then all the bigger ones, having the bigger diameter collar is okay, but we just want to have the minimum size good. So this is 371. I can't tell what the height is, 0.371, because it's not just letting me take this thing apart. And then here, 9/16. Here, 0.371. Okay. And then obviously this is as built, right? This is as built. So obviously the tolerance there is high, and the tolerance here would be low, on the low side, right? Okay. And then also, if we want to use the same wrench, we could do that as well. So this is 0.6. Let me turn it sideways here so I'm not hitting the hose with the depth indicator here. Okay, 0.615. Alright, and then like I said, the depth here. Oh, and also what's the thickness of the piece here is it's about 3/8. So the flange is about 3/8. So this piece here is 3/8. Yes, this is way too small. 0.325, and this one is 0.615. Yeah, it's just a little bit bigger than the OD. Now it should be 0.6 from 615 from flat to flat. Yep. And obviously it's longer, and obviously in our case we're not going to get the threads all the way up, but that's okay. I mean, we could always compensate by sticking the tube out a little further. So now we should have this, and we should have fitting with collar assembly. And so we could go here, collar, save, fitting, save, update. There it is. So there's the tube. Also, another thing was the hole that's going through it, the clearance hole. I think that's way overkill for the clearance hole. That's okay. I mean, again, here I could take it all apart and pull the collar out, but I mean, here we're pretty safe as far as, you know, 1.5 times D height. But I'm sure that this collar is taller. I'm sure this collar probably goes all the way down to the 3/8, so probably 1/2 inch tall. And I think this is 3/8. I could bump it up to 1/2 inch if I need to, because also obviously this is going to be harder to machine and higher chance of losing it. I mean, not really harder to machine. You go in here, you part it off, not a big deal. And I'll probably make these parts myself, actually. I'll go and get a cutter, and then I'll just probably make these myself. So, but I'm guessing that is probably the that 1/2 inch. So that way you don't. Well, here that would mean that you jeopardize a lot of the thread up here. So here we have a lot of unjeopardized thread. I mean, we can make it 1/2 inch and it goes halfway up, and then we have this thread unjeopardized. But 1/2 inch thread is 2 times, basically. So that's still in the rule of thumb. So that's on the high end. We should probably do that. So yeah, let's just bump it up to -0.5, 1/2 inch. And I agree, it should be on the safer side. That's kind of the high side of really where you're not gaining any benefit. Let's just do this. Okay. What about this bore? That bore. -5. There we go. And then we could go through and change all the stuff over to 2 times. Yeah, there you go. Now it's 2 times D. Which, you know, I'm fine with. The other thing is what the actual thread is on that piece. I don't know. Also that, let's see. The actual, that's what it looks like, this little stub guy. Okay, so then basically what we would need to do after that is after we've done that, I mean, it doesn't really change anything elsewhere. It just changes this part, right? And it's just changing the internals. So now you'd go to the 7. What the heck? Strange. Oh, this is newest one, so this is probably the older one. Oops. So this is Oh yeah, 7/8 is that one. So basically what we're gonna do is for this one, this is, I think, now this is going to change a little bit there, but that's okay. So now this is 0.75, and we'll just upgrade this to, oh, this is a 1/2 inch. So 2 times is 1 inch. So basically change this to 1 inch. There you go. There's 7/8. And then we go here, that's fine. Here, then we need to go here and we need to increase the depth of drill. And make it go down another 1/4 inch. Basically 0.375. There we go. Now it should be okay. Shouldn't change this height here. Nope. Okay, cool. Alright. So that's good. That's good. That's good. And that's good. And then this could also be that same height, where this is 3/8 of an inch tall. Where did I set this as? 1/2 inch? I mean, yeah, right now. Because I think the wrenches are a little bit thicker the bigger they get. Okay. And the last one is M14. M14. Where's M14 orifice? I mean, collar. Oh, I think I have it the same as the 7/8, I think. Oh, 9/16. Alright, it's just a little taller in this case. So, oh, now we need to basically change the M14 fitting, or now it's 1/2 inch tall instead of 3/8. So this minus 1/2 inch. 1/2 inch. There we go. Save. There we go. There we go. Now, I mean, because if I'm going to machine it, I could kind of do custom stuff if I wanted to. Spec, section analysis. I know we're running a little bit over time here, but that's okay. And there you go. Right? Cool. Hose mock-up. Everything fits. It's all the same size hose, so it's not a problem. Okay. So it looks good. Hose is updated. This 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 needs to change. That piece on the top. There you go. That's what it actually looks like. Okay, so that's basically it. So now I could go and send these to myself and get them quoted with some of the machine shops I like to work with, and see what type of deal we could get, and then move forward with buying the rest of the electronics. Oh, and then we need to print maybe a garnet. I'll probably need to print a garnet holder. I have my printer back up, so we could do that. Print this garnet holder. And then put a little piece on top there, and then that will hold all my stuff. Alright, thanks for watching, and if you like this video, please subscribe for more videos like it. I'll see you guys in the next video. Take it easy. Peace.